this material, you will learn about the oscilloscope tool integrated into the Model 2 KME NEVO-SKY Direct driver. This unique tool measures signals in direct injection engines, is located in the Direct Oscilloscope tab. This feature enables the gathering of current and voltage signal traces, which proves incredibly useful when diagnosing the gas system. The view is divided into the waveform window, where the recorded time waveforms are displayed, cursor values for every displayed waveform, and the settings section, allowing you to initiate waveform acquisition, clear the stored traces, save or load the waveforms, or choose the oscilloscope operating mode. The available measurement modes for the oscilloscope include the following: injector current, injector voltage, signal detection, analog inputs, and manual mode. Signal detection is mainly used to identify the gasoline injector wire. Keep in mind that the measurement probe used for gasoline injector signals is the gray-black wire from the ECU harness. By employing a sharp-tipped probe, it is possible to pierce the gasoline injector wires to perform measurements. For this type of measurement, we recommend the automatic mode, where measurements are done continuously. Once the wire is properly pierced, you will see 8 sequential signals displayed. To save the collected waveforms, press the stop button, which will gather the waveforms and subsequently display them. The waveform shape tells you about the measured wire's side, either the control or the power supply wire. The control wire is one where thin spikes occur, while the power supply wire is one where the signals remain constant. There are also 2 gasoline controller types. These are the paired and the unpaired types. You can recognize them by looking at the signal of the control wire. In the case of a paired controller, the signals will change, but for an unpaired controller, the signals will remain identical. Of course, the waveforms differ for individual controllers. However, by comparing the waveforms of the pair of gasoline injector wires using the signal detection option, it is possible to determine both the wire type and the type of gasoline controller. After collecting the waveforms, you can save them by pressing the To File button. Make sure to save the file in a clear manner, placing it in the folder reserved for that particular vehicle, recording the date of the measurements and what type they are. If you press the Start button again, any unsaved waveforms will be lost, just like switching to a different mode within the oscilloscope. So saving the data is very important. The injector current measurement is used to gauge the current passing through the gasoline injector. For this measurement, 2 wires are utilized: B1S, which is gray-black, and B1W, which is gray. You can measure the injector current while running on both gasoline and gas fuel. This mode is used to analyze the waveforms from the gasoline injectors. After collecting the data, the injector current will be highlighted in red. This view displays the opening phase, the holding phase, and the closing phase of the gasoline injector. At the end of the waveform of the overvoltage resulting from the injector closing is drawn in green. It is also possible to measure the essential parameters of the graph shown. 4 cursors are displayed on the screen, 2 horizontal and 2 vertical. Their values are displayed in the cursor values windows. By clicking on the cursors and moving them, you can change their position. Alternatively, you can select the cursor you are interested in and move the slider control or use the arrows. In order to measure the rise time of the current spike, position one cursor at the base level and the second one at the peak of the rising edge. Now you can read the duration time. This value is shown in microseconds, amounting to 340 microseconds in this instance. Horizontal cursors measure values. Measure the maximum current value and the holding current by adjusting the markers to their correct positions. You read the value in the readings window. In this case, the current spike reaches a value of 11.5 amperes, and the holding current is approximately 3 amperes. In injector voltage mode, you see the voltage waveform on the gasoline injector. You can do this while simultaneously displaying the results from the current measurement. Remember, in cars with an unpaired controller, you cannot perform this measurement. Just like with the current measurement, you are able to take the required measurements here. Because the current measurement and the voltage measurement were performed at different times, they may not overlap with each other. The next mode displays analog input waveforms. You can display waveforms from any input. Please remember that inputs numbered 1 through 4 allow measuring voltages from 0 to 5 volts, whereas input 5 from 0 to 20 volts. Input 5 is useful for identifying which high-pressure pump valve wire needs to be cut if an external EZP valve emulator is being installed. You can find the specifics in the EZP connection schematic. Input 1 is for the high fuel pressure sensor signal. It is possible that in a given car, the sensor is digital. If this is the case, the signal will fluctuate and will not rise in proportion to the pressure variation. You must then choose the high pressure emulation setting from OBD CWO. The correct signal should have a constant voltage value, about 1.5 volts at idle, and it should increase in proportion to the engine load. To obtain further details, we recommend that you review the user manual for the KME NEVO-SKY program.